as we just saw on the board, you could have two-dimensional array of bit cells where each bit is just storing one bit, and then using that address to access this. Here is an example on the slide. If you have a 2-bit address, that means that we have 2 to the power 2 locations. In this case, we can address 4 locations, and then the width of the memory is really this here, the 3 bits, and the depth is like how many items the address bars are addressing here. So the size is 2 to the power n times m if you're talking about the size in terms of the number of bits. Here, basically what we say is the 3-bit word stored at address 10 is 100, and that's typically how we go through this memory array examples. But now let's take a look a little bit deeper what it means when we talk about memory. You guys have all seen this constructs in logic, and let's first see the protocol, how this works, and then go through the logical expression for this. When we talk about a memory array, we're talking about a bit stored somewhere. The bit stored is connected to a word line, which enables that storage of the bit, and the bit line is what enables the value for this bit coming in and out. Now, typically when we write or read, what happens is, when we then we are going to be having multiple word lines connected to the bit line. So we are going to read only the address encoder. The decoder makes sure that you connect to one of the words at each point of time where we are reading from a usual memory array, which is like a 2-dimensional array. There are different arrays possible nowadays, but we are talking about the most simple basic case. And now the other values that are stored, that are going to the bit line, they should be high impedance because they should not be impacting what is happening. So when we assert a word line, we put a 1 on it. When we desert it, we put a 0 on it. Now, what happens is if you're trying to store a bit line, if we're going to assert the word line 1, and then the bit line is saying what is going to go in the memory if you're asserting it, and then once it is disconnected, it's in the high impedance connection. Now, just putting this whole together, the word line is really an enable. So remember, we are enabling only one of these lines at a time, and we are asserting either reading or writing to that position. Only one of the word lines is high at once, which means that we are only reading or writing to one of these lines at once. Next, we will be talking about different types of memories and how they can help us in instantiating logic.